recording this.
Okay.
Sorry, I have.
So what we do see is that, like on the news, in the political rhetoric, or sometimes even in public rhetoric and social media, you hear a lot about the migrants. And people refer to migrants or the threats and everything. And what happened in 2015, I'm talking about especially after the Syrian civil war, we had more than 1 million sea arrivals only. I'm not talking about people who cross the borders. And UNHCR already said that thousands of people lost their lives, and we failed to predict the numbers. I don't know if you're familiar with the Middle Eastern context a bit, but in fact, the Syrian civil war and the conflict did not start in 2015. It started in 2011, even in 2010. And so, how come when we were talking about a potential war and conflict in general, that we did not expect, that Europe was very surprised with the number of arrivals and millions of people being displaced? Because most of the policy is based on very numeric forecasting models. And forecast in this context is not a chart. So we are not talking about forecasting some stocks. We are really talking about people and human beings. So what happens is that based on the forecast, the decisions have huge impact on people's lives. For instance, Frontex, which is the border agency of the EU, had a risk assessment in 2014. And they said that the central Mediterranean route projected declining number of arrivals. However, the number was only for Italy, more than 150,000. So the reception capacity totally collapsed. And Lampedusa, maybe you have heard this little city, they only have 6,000 residents, but every month they received more than 8,000 arrivals to the city. So the people that we are talking about here are not the data point, but the forecast which failed to anticipate the number, and they were the points. So we really started in 2010s with the forecasting and the predictive models to predict numbers per se. So how many people, when and where. So today we will talk about, almost in half an hour, I really would like to take you through this chain of consequences. So what has happened and how we can make things better for the next years or currently. Why it matters? Because we do see in the news and the rhetoric in our own talks that when you talk about numbers, it's more trustworthy. So a lot of people use, okay, when you talk about the numbers, predictions, people are more prepared. But Eurobarometer, which is one of the major perception measurement scale for the EU residents, when you ask people about the percentage of population who are foreign born, the median public estimate is about 22%. So they think that every other person in 5 people are of foreign origin. So they are born somewhere else. So they're migrants. However, the actual rate is less than 8%. So as you see, it's almost triple than the reality. That is something that we can really use to understand the overall context of the rise of right wing and the discussions that we are having a lot. So when we talk about prediction and the predictive models, it's not only to serve the policy, but it also shapes which number, 8% versus 22%, wins in the public understanding. So the forecasting models so far have not been the most successful, I have to say. Because if you have heard, in 2024, there was a very interesting case. Suddenly, in a Canary Island, of Spain, which is a very touristic island, they ended up with thousands of people arriving in the island in few days, which was totally unexpected. And more than 10,000 people died when they were trying to make the way. But what is interesting here is that in a single day, the Spanish minister had trips to Mauritania and Senegal to really, even Gambia, they want to understand how can we stop this. So when the prediction model or the predictions fail, the response is way faster than our scientific understanding and scientific responses. So it does really matter that what we give and how the models work have real impact on policy, on society in general. So in addition to this predictive approach, because there is a huge critique around predictive models and especially computational models and methods when we talk about topics like migration. It is also about to serve who. So we can talk about the predictive policies, yes, but we do know that policy and the policy misuse of a lot of scientific information is not limited to predictive models or the AI in general. But there is another fact that we need to foresee is that these predictive models are super useful because we need to plan the reception capacity. I mean, reception capacity, what I mean is, if you remember, for the ones who were in Turkey in 2015-16, when the Syrians arrived in Turkey, in the borderline, we really needed reception centers and we didn't have them. They cost, they need time. So the reception capacity planning is very, very important to allow people to have bad staff, translator, legal aid, and in general, like how we can work with the projections. And the border operational resources are important. Humanitarian appeals are very, very important. And of course, a national asylum policy is agreed based on what to expect. And I think if you remember more recent things about the Russian invasion of Ukraine, we had the same thing. So recognition rates, processing capacity, and the detention decisions are all relying on the forecasts. So I would like you to check to get your mobile phones, because I'm not there, but please check the QR code. And it's a very, very basic question. And there is no right wrong answer at this stage. I would like to hear from you. How many climate migrants will there be in 2050? I will wait a few seconds. So we have only one person who voted. So 2, 6. Akın hocam, how many people are there in total?
26.
Okay, 20 something. So we can wait till 20 at least. See, 13. Okay. A few more we're expecting. Yeah. So I will come back to this because I think most of you think that there are more than 200 million. There will be more than 200 million. I mean, let's say, okay, so some change ideas about the climate migrants. But what does the model or what do the models tell us? So you see, these are the most recent models. One is from the Internal Displacement Monitoring Center. The other one is from the IOM, the United Nations Migration Agency. So the published estimates in general vary very, very a lot, because there are some estimations around 25 million and there are some estimates around 1 billion. So, and there is no way to say that one predictive model is superior to the other one. However, this is what we have to work with. What you see on the right-hand side of the slide is, it says global warming could create more than 100 million climate refugees. So suddenly we heard a new name because it was a climate migrants. Now we are talking about climate refugee. And then when you look at the continents, or the areas, you see that East Asia and Pacific, Southern Asia, Asia, Sub-Saharan Africa, Americas, Middle East, and Europe and Central Asia. And here, the pessimistic, I mean, and below what you see, let's say bluish, purplish, the pessimistic reference, and the yellow one is the more climate friendly, like if we make everything right scenarios. But in all cases, you do see that Sub-Saharan Africa and East Asia and Pacific will be affected a lot. So how can we decide which number is the correct one? So the estimates are almost 40-fold spread. So why do you think, I mean, where do you think the disagreement? Are we talking about different futures? Are we talking about different concepts? Are we talking about different statistical methods? Because these are the major estimation reports like World Bank and Groundswell. It says more than 200 million. And Myers and IOM, it was in 2005, it was about 200 million. Christian Aid, up to 1 billion. The IPCC, which is one of the most recognized authorities, I would say, they say there is no headline, and the recent lower bound academic estimates are 25 to 50. As you see, the most conservative ones are usually the academics when doing that, because we really spend a lot of time to understand what do we mean by climate migrant. So who is the climate migrant? So based on, I mean, what you see here is coming from this Groundswell report. So they say that there will be 216 million of people, like, and you see where they are. But the, let's say, trick here is they are really talking about a particular type of people who they call a climate migrant. So here the question is, in fact, for us, assume that there is a woman in Somalia and she leaves her drying district where she has a lot of drought problem during a governance crisis where armed conflict is an everyday reality. Okay. And then she decides to move when livestock prices have collapsed. And she also has a cousin who is already in Kenya. Okay. So I already gave a very brief profile, but a lot of things that might affect her decision to move. And let's see. So is she a climate migrant? Is she a conflict migrant? Is she an economic migrant, or is she everything? Or is she an asylum seeker, or is she an internal displaced person? I do know that for people who are not really studying mobility and migration, they might think that they are the same things, but they are definitely not. So migration, I mean, migrant and a refugee are not the same thing. All refugees are migrants, but it's not the other way around. So in this case, we are moving very slowly to our independent variable selection because we really would like to understand the drivers of the decision to move. And I don't know why it doesn't go. Okay. So, and the word that drops out in most of the retellings, because when you read the reports, they say internal. So they say that we're going to have that many million people who will be internally migrating. So in fact, that is least of all the international concerns because we are, the fear is that all those people will flood to Europe or the other countries. So let's say in Groundswell, they say more than 200 people will move within the countries. And according to UNHCR, 60% of all forcibly displaced people never cross the national border. So in fact, these will matter a lot when you're going to have your hands-on exercise too, because we really need to be very clear about our dependent variable too and the vector. So what happens with LLM is they should make things easier for us, right? But assume that you're feeding a news article, a tweet, or a post, a policy document, or a description of a district into a new LLM-based encoder. It could be a sentence transformer or an OpenAI's embedding models or coherence or whatever. What comes back is not a summary or a category. It's a fixed length vector. So, of course, it can be like, I think it is, if I remember it right, it's 384 to, it can go up to 1,500 something numbers long. So each number is a dimension of the embedding. So none of you, and neither me, can tell you what dimension 35 means in a plain language. So they are latent features in the model that are learned during the training. Some of them can carry very meaningful signal about the text, so we can identify them, but some basically don't. So the practical solution here is that in one document, the hundreds or thousands of numeric predictors, that's the raw material on an LLM augmented pipeline that you will get. So once you have that per document, per month, per district, the number of predictors explodes. So in most of the migration research and the predictor models, we have at least 30 to 60 month observations to be able to understand the time series effect. So in fact, we have enough time points. And if you're working with weekly data, it's even more. And in the LLM augmented pipelines, or K, can exceed 1,000 in a single data set. And the ratio here explodes. That's why the naive fits do not work in this case. So in a very, let's say, straightforward regression line or equation, if we can't isolate a marginal effect with 20 predictors, what's going to happen if we have more than 1,000? So this is a very important question here because it's a rhetorical move that we have to connect the technical setup to what we already believe as researchers, like when we are trying to model something. So, like even with three, like remember the earlier slide, climate, conflict, economy. It's so difficult to isolate climates because what we do know in the regions where climate has a direct impact of resources, then there is scarce of resources, which creates economic problems, which creates or usually influences the armed conflict as well. So they're so intertwined. So going back to this dimension 35, what is capturing, it's mostly noise. So here our problem is not only conceptual or only statistical, it is both. That's why, yeah, I think we can easily say that LLM doesn't really make everything very easy, especially in terms of the variable selection. So Un unfortunately, for the migration modeling, we are still stuck to 19th century approaches because since Rammstein, who said that, like migration is a gravity model. So it says that, like, oh, like where you have more resources, people tend to go there. But now we do know that it is way more complex than that. Like a lot of young people in the world, they want to migrate to somewhere for a reason or another. And it is not anymore it's not anymore only for economic reasons. And several studies, especially currently, show that in the authoritarian regimes, economy doesn't really matter for a lot of people directly. So, what I'm trying to say here is that the gravity tradition cannot help us to understand when you have only the fixed effects and interpretable coefficients. So, coefficients are assumed to be homogeneous across all origin and destination dyads because we are now working with dyadic relations mostly, and coefficients assumed constant over time and almost never tested on the future. So the forecasting with these gravity models really fail us. That's why we also go beyond this. So just to remind that prediction is not an explanation. So it does not answer us the why question, like why it happens. We can talk about drivers, we can talk about influencers, and it does identify a causal effect, but it requires theory. So data-driven approaches in general start from what you have in the theory, in the data. But in social science applications, we usually start from the theory to understand how things run. So in the prediction that but in the prediction, we try to minimize the expected error on data that we don't see or we don't have yet. So, which allows large K and it penalizes complexity. So, it means that generalizability is a bit of an issue because in a predictive model, you can work excellently on one case, but it can be really terrible at another. So, in general, we treat in the migration and mobilities research, we treat forecasting as an explanation problem for a century, but it is why it does not forecast, because forecasting is not the explanation. It's more about the prediction. So the cross-validation time series really helps us. So I'm going to tell you a little secret that I usually deny everywhere. In most of the cases in the predictive models, time series like the basic ARIMA model works so well that sometimes you don't need very complicated models for the basic understanding. However, if we really would like to understand how it's going to work, what we do is we try to leverage this advantage of the time series. So the cross-validation is where we assume exchangeable observations. So we are working with this little movements of the training, of the rolling origin cross-validation. So what we train is we train the data on month 1, then 2, 3. So it really goes up to month T. And we really try to extend the window, and of course we refit and then we repeat. So it's really a kind of a repetitive study. So in this case, we do not use any future information. So the training is purely based on what we have. So what we do is we predict the period that we already know, then we go back and correct if needed. So the set of selected features, I mean, if I can underline, I'm not talking about variables, I'm talking about selected features. They become time series in its own right. And then we can really see the drivers appear, persist, or vanish. So this approach really helps us to get rid of all the assumptions that the gravity models want us to keep. So, of course, I mean, I think you have access to the paper. You will see it. So, in general, we are talking about the regularization of the model. We are not talking about regularizing something else. But here, we are talking about the ridge, we are talking about the lasso, and we are talking about the elastic net. So there are different methods. Elastic net used to be one of the major ones. We will come back to that. It started with Karemio's paper in 2022. So in our paper, we try to go beyond that. So here, the game is very simple. What is lambda? Okay, so that is the entire logic of this predictive model. So what you see here is, we will come back to this figure again. So the red part that you need to get your attention to now, because the lasso is analog of R square, and the R, which is the red part that you see, keeps improving as lambda shrinks. So with the K in the hundreds of thousands of T, I mean, in this case, we had it in 40 periods, and the R selected models are overfitting, but we will come back to this. So normally the R is a deviance ratio, and we will talk why it is important to compare. So here is, oh, I don't know what I did with the animation, but here is a question, okay? Based on what you heard so far. So there are two data scientists, and they are working with the same 1,000 features, and they have the 40 months, the same time period. So they come up with two models. Model A, which keeps 55 features, and predicted the test sets with slightly lower error. And the second model of the second scientist kept only 12 features and predicted slightly worse. And the question is, which one do you trust more? Model A, because it forecasts better. Model B, it is more parsimonious. And I don't know, neither. Twelve people, 13. Let's reach 20, then we can go back. Okay, so if I go back to the previous slide, we are talking about 55 features versus 12 features, slightly lower error, but worse prediction. So we're going to come back to this, but I want to see the results of yours. Okay, almost half said that I need more information, and the other half almost went for the parsimoniousness of the model. In fact, what I would say that, like, if you go with the A, I think it was the minimal, we had only 14%. So we cannot distinguish a genuinely better predictor from a lucky one in the sample. I think that's why, like, the number of features do not matter, because we don't know which ones are they. And then 43 of them, in fact, for instance, can be from the LLM embedding dimension, so which means they have no meaning at all. So it might predict better just by coincidence. When we check the model B, I mean, first give me the negative sides, and then we can see which one to lean forward to. And this, it is sparser, definitely. But what if we select the wrong 12 features? Remember, we don't select the features here, the model does it. So it can be at even a higher variance, so fewer features is not better when it correlates with the more of the right features. So because we don't know which features are selected. So as you see, it's not about the number, it is really about the features themselves. So the true drivers versus spurious. So normally how we compare the models is looking at the RMCA. However, in this case, it only gives us the standard error of the difference. But assume that you're going to give this model to a policymaker, saying that, okay, this is how it's going to work. And the test training period has any structural breaks or not. So in short, we really don't know. So the correct answer is not I trust prediction or I trust parsimony. It is that I don't know, because we really need to know which features are selected, how the RMCE are. So in fact, neither of them is the correct one. And I mean, I think many of you already got it right about having it, we need more. So going back to this figure that I gave to you about the DR, the deviance ratio. So, I mean, the penalized deviance ratio is something that we proposed. And what do you penalize it? So when it makes a wrong selection, we penalize the model. In this way, in a way, we teach it, or it learns to go with a better selection of the features and the stronger ones. And so it is really the same math trick with the R square. And the elastic net already has a regularization path, so we use that one. The only thing we do is we really try to correct it based on different time lags. So the PDR is a concave lambda. So what we try to have is a real interior maximum. It balances marginal gain and fits against marginal cost of complexity. So what I'm trying to say here is that you can have a super complex and very well-fitting model, but if you cannot explain it, it doesn't help you. So it is really between having the, let's say, the balance between the complexity and the interpretability of your model. So in this case, the model A, 55 features, included 43 spurious LLM embeddings. So which means it's not the better one, but the plan model B was a PDR selected. So when you know more, opting for the model B is the right one. So this is not only about the mathematics, it's also about the application and the conceptualization of the issue that we tried. So this, how we come to this point, I think we need to thank and give credit to the earlier studies, because our initial idea really inspired by Karemia's work in 2022. If you're interested in predictive models and machine learning models, please have a read. It's a really brilliant paper by Marcello, Stefano, and Tom. So here they propose the dynamic elastic nets. So probably you know about the random forest, for instance. So these are the old type of machine learning models, but dynamic elastic net is one of the most recent ones. So here you just use or you just tune lambda based on the standard CVO deviance ratio. And then we published a paper in 23 where we worked on the flow of specific temporal gravity. So we really try to allow the parameters vary by dyad, like which means between two countries and also at different times. So within the dyadic variation was, what I mean is we allowed variance in every single route, like for instance, Syrians to Germany, Syrians to Belgium, Syrians to Sweden, kind of way. And then our most recent paper, which was the core of today's talk, is the one that is published in International Journal of Data Science and Analytics. What we did, we combined them all together. We got the dynamic net, we got the FTG, and we used the subnational satellite predictors that we created through some like Earth observation analytics. And then we had the PDR, like the penalized deviance ratio. So it fixed the overfitting under high K and low T. So I think the next way to go, so now we are working on the LLM as feature generator, because most of the time in our models, in the migratory flow predictions, we use LLMs to understand the context, like climate conflict or the political situation, even for climate, and it's also being used for the public perception, what people talk about. So the bottleneck is no longer the text, because we have more than enough text, but it is the selection. So which one will work better? I'm not gonna go into detail, but especially for the opinion and the narratives, the data is super biased. So what is being talked is very different. Like assume that you are working on an Arabic data set or data available, whose LLMs are trained on only Al Jazeera information. So there is huge biases and the problem. So the model and the feature selection is super, super important. So to wrap it up a bit, so we work with rolling windows and with the PDR. So we have the data, then we had the lead lag analysis, we had the tuning and training, then the model selection, and we tested. We worked the exploratory analytics, and then we come up to predictive analytics. So in general, what you see here is that fitting elastic net, what we expect you to do in your hands-on session as well today, a fit elastic net on rolling training windows, select lambda by PDR for within each window, then track the evolution or the changes in the widgets which are retained across different windows, and then forecast held out months. So benchmark against the ARIMA 1. Okay. So at the end, what we got a model that predicts a set of drivers we can defend. I think the last part is very, very important here. And of course, for each origin destination. So to give you an example of the results, we analyzed, because we worked on Somalia for long years, and as a part of the Hummingbird project and the Climb project. And what we found is that in our model, with our predictive model, we had almost 80% improvement in the prediction interval score. And then we allow drivers to vary destination, and we don't talk about one climate refugee story because we allowed different features to interact. And some drivers are very persistent, like conflict, like governance, and some were more transient, like economic conditions. But I think it is not rocket science, because if you start from economics, you will explain, because even even a basic GDP explains everything in a regression model, but we do see it more like an intermediary, because the conflict in governance influences economics, which the conditions and which affects people's decision. So we haven't seen any black swan drivers in our study window, and we are not selling a story. And we say that it's a feature, like it's not a bug. So we really try to explain the meaningfulness of each I couldn't talk of each feature that we select. So the question that I want to leave you with is, which K that matter you will decide to keep or not? Because LLMs can help us to generate features from an unstructured text or entity resolution or multilingual coverage, like given the existing limitations with the understudied languages, but it gives us richer semantics than the tone scores alone. But they fail to gap the existing or let's address the existing gaps in terms of the causal question, interpretability of the drivers, or the forecasting itself. So we can use LLMs with the case, and the PDR helps you to keep the ones that matter. So for your, oh wait, not now, go back. Okay, what I did is, okay, for your hands-on session, I wish I could be there with you, but I know that you have an amazing team there who are going to help you. I made up a country. By the way, the real data of our article is online, so it's public. You can also try that. But I think it will be a bit more fun to try something that I made up, because I'd like to introduce you to the country, the Republic of Calderia. So the Calderia is a fictional country in Africa, and it sends migrants to 4 destinations, and the destinations are Alpha, Beta, Gamma, and Delta. Okay, so one of them is driven almost entirely by noise. What I mean is, when I was generating the data, because you're going to work with synthetic data, I planted real drivers from 3 of these 4 destinations, and conflict in specific districts, drought signals for the climate and economic conditions, and some real relationships. But for one destination, I planted essentially nothing. So it's just pure noise, okay? And if your model, because when you work on the model of these destinations, if you find anything in this noisy country, your model is fooling yourself and itself. So there is no right answer here because it's going to depend on the models that you will fit. Would you please bet? And please keep your bet in mind in the hands-on session. Which destination country is driven almost entirely by noise, not by. Sorry for the typo. So alpha, beta, gamma, or delta? Let's see. Please keep a note of what you voted for, because that would be really nice to talk about them after the hands-on session. Let's reach 20. 18. One more. Give it a push. Yeah, okay. So a lot of people assume gamma. Let's see if it's the case. I might have some statistical biases towards Greek letters, but we'll find how it will work. So welcome to Calderia. You're gonna have 30 districts in this country and 4 EU destinations during 48 months. So what you have in your data set is 120 traditional features plus 450 LLM embedding dimensions. So the ratio K divided by T is almost 40. You fit ElasticNet, and you're going to compare the deviance ratio and PDR, like penalized deviance ratio, selected lambda. And I want you to inspect what each criterion capped and what is missed. And then your TAs and Acknowledge probably will reveal you the ground truth, because there is also the ground truth data. So one destination, as I said, is mostly noise, and one has a regime shift. So good luck. I don't know how you are going to plan, if you're going to have a break or not, Acknowledge.
Yes, so we have your materials in Drive. Is there any files you sent us that they aren't supposed to see?
Yes, ground truth. And
Okay.
also the all checks, because all check is for the TA, so they're going to see everything that students can have as an output. So here they should get the Caldoria data set
Yes.
and the hands-on R data set. I think those two will be sufficient for them.
Yes, now we are sharing those data with the class. And can you once again tell us very briefly what is the challenge again?
Okay, so the challenge is they do have a data set on a fictional country called Caldoria, and we are trying to predict the dyadic, like the flows, migration flows from Caldoria to 4 different countries, alpha, beta, gamma, and delta. And the data itself has the traditional features, which means coming from the administrative data mostly and some satellite data. And they do have 450 LLM embedding dimensions. So the ratio is, as we said, the country has 30 districts and 4 EU destinations and 48 months. That's the time duration. So they have to work with months. So I expect them to fit an elastic net, and they're gonna have the deviance ratio and the penalized deviance ratio. The code is there. So they just need to see how to select the lambda based on the outputs. And then at the end, you can share with them, once they have their model set, the ground truth data, so that they can compare if that is a good one or not a good one. So, and of course, this little game in this is that, can they guess which country, which destination is the noisy one?
Okay, wonderful. So in the next half hour, they're going to do the challenge, and 15 past 3 Turkish time, we're going to reconnect back to you, and everyone is going to present what they found.
Okay, that's soon. So only half an hour will be enough. That's perfect.
Okay, what? Gel buradan sonra. We have a question.
Okay.
Hocam merhaba, Çiğ benim. Caldoria Ground Truth CSV file'ı da ekleyeyim mi? Öğrenci tamam, onu tamam. Okay.
No.
Okay. We will reconnect in half an hour with you.
Okay.
Thank
Okay.
you.
Bye.